Hey folks, how's it going? This is Mr. Moray coming to you with another video. This one is on inverse functions, which are also, if we think about it, functions that undo one another, okay? So I'm making this video to give you a crash course in a couple things, and that's one, how do we find inverse functions? So actually, let's do 3 questions. What are inverse functions? 2, how do we find inverse functions? And 3, here's going to be another question. What do inverse functions look like? I guess I'm going even into a 4th. Okay. How do we confirm that functions are inverses of one another? Okay, so in this class, these are the 4 questions, and there may be more, but these are kind of 4 fundamental questions about functions and their inverses that we are going to ask. Now, it's important to preface this by saying that not all functions have inverses in a sense. And when we talk about graphing, we are going to have to talk about how we'll have to modify the domain of certain functions such that they will have inverses, okay? So this video is not to tell you how to know when a function has an inverse. It's simply to answer these 4 questions. What are they? How do we find them? What do they look like? And how do we confirm that they're inverses of one another? Okay? So what are inverse functions, right? Inverse functions are functions that simply undo one another. Let me give you an example. Here's 2 functions that are inverse to one another. Let's talk about this. Let's talk about f of x equals x plus 6. And this is my notation, f inverse of x equals x minus 6. These functions are inverse of each other. They undo one another, right? In a sense, you could even call them opposites, right? The opposite of adding 6 is subtracting 6. If I take a number and I add 6 to it, and I take the output and I subtract 6, I'm back where I started. So for example, if I take 0, I plug it in, I add 6, I get 6. If I take that 6 and plug it in, I get 6 minus 6, which is 0. Now, we've talked about this idea in one of my previous videos, which is about composition, and I really encourage you to take a look at my composition video so you can understand that component of it. But today I'm going to talk about to you one of the main concepts is how do we find them? Okay, so I'm going to give you a couple different examples. Here's my first example. I want to know, let's let f of x equal 3x plus 5 divided by 7. And I want to know, what is the inverse of this function? So when we find inverses, there's a few steps you got to take. The first step, okay, we're going to replace f of x with y. This is actually a notational thing. We're used to seeing y equals and f of x equals are essentially the same thing. It's a matter of how you write it. But also, y is on our calculator, and it somehow, in some sense, is convenient because when we want to visualize this on our calculator, it will help to have it look like y equals, so we can actually plug it in and see if these things are equivalent. I'm not going to talk about plugging it in this video, but I will, for some of them, give you a rough sketch of what they look like. That's the hope. Okay, so we first start by replacing f of x with y. The next thing we do is we swap all x's and y's. So wherever we see a y, we write an x. Wherever we see an x, we write a y. So they flip places. Okay? The next step is to get y alone again. Because we're used to seeing things as y equals, we're actually going to want to get y all by itself again. Okay? And then the fourth step is replace y with the F inverse symbol. All right? So I'm now going to show you how this would work here. Okay? So step one is let y equal 3x plus 5 over 7. Okay, I'm now going to do the replacement. So I see a y, I'm going to write an x. I see an x, I'm going to write a y. Okay? See how I did that? But we're not really used to seeing x equals. We want to see y equals. And in a sense, and I talked about this in class, what I'm doing is I'm essentially giving you a formula to get x alone. This is what I'm going to do is in this equation, if I get x by itself, it's the same thing as getting y by itself here. It's just a matter of notation. And honestly, that's why I think this is a confusing topic. And I'll tell you, the first time I ever learned it was in college. It definitely confused me. I didn't learn about it in high school, even though it's considered a high school topic. So if this is tough for you, that's okay. And so I hope through this practice, we'll get more confident with it. So now we need to get y alone, okay? That's the third step. So my first step is going to be to multiply by 7, because that will cancel the 7. And what you do to one side, you have to do to the other. So I get 7x equals 3y plus 5. Now I subtract 5 on both sides. I get 7x minus 5 equals 3y. And now I divide by 3. And I get y equals 7x minus 5 over 3. Okay? And let's think about it. This, again, is a formula for if I was to make y equal to, I don't know, 5. How would I solve for x? Well, first I'd multiply by 7. Then I'd subtract the 5. And then I'd divide by 3. Okay? The last step is, remember, you replace the y with f inverse of x. And this indicates that these functions are inverses of one another. Now, how do I test? Remember, to test, you use the composition. And again, I'm going to remind you about the video I made on compositions. What I'm going to do is I'm going to take this formula and I'm going to plug it in here. Okay, so let's take a look. So I'm going to do 3 times 7. I'm sorry, this should say a 3. I didn't copy that over right. 7x minus 5 over 3. Okay, I'm plugging f of inverse into f. Okay, and let's look at what happens. Well, when I'm dividing something by 3, if I then multiply it by 3, these things cancel out. Then the negative 5 and the 5 cancel out. Then the 7s cancel out. And look, I have x. So what happens is when I evaluate this, and then I evaluate it on this, those undo each other, and I'm left with where I started. Let's see if I do it the other way. So now I'm going to plug the original into the supposed inverse. And if this works, then I have an inverse. So notice the quick canceling here. Boom, something cancels, rather. Sorry, 3x plus 5 minus 5 over 3. Then boom, something cancels. 3x over 3. Then boom, something cancels. So we see that quick canceling and kind of boiling down at every step. So what this means is that confirms these are inverses of one another. And that is the composition of functions. Taking one of the rules, plug it into the first, then taking the first rule and plugging it into the inverse. And if it gets me back to x, which is where I started in both cases, that shows that it is an inverse. Okay, so I invite you to take a second and kind of go back and digest this little example. And then in a second, I'm going to move on to how does this work with polynomial and square root functions. All right. So I'm going to show you a couple things. Let's just show you a couple roots. So I want g of x equals x plus 2 square root minus 6. Okay, over here, I'm going to do the cube root. How about 2 times the cube root of, I don't know, x minus 5 plus 10. So let's find their inverses. So the first step is we're going to write them as y equals times the cube root. Okay. The next step is I'm going to do my replacement, right? So here's the replacement on that side. Okay, they've switched places. And now I'm going to get x alone. So let's take a look over here. So the first step to get y alone is I'm going to add 6. So I've got x plus 6 equals y plus 2. And then remember, how do I undo a square root? What cancels out a square root? Well, that would be squaring. So, and I love that someone said this today. I'm going to square both sides. So this I'm going to leave as y plus 6 squared. And this becomes, or rather x plus 6 squared, and this becomes y plus 2. And then I subtract 2 on each side, and I get y is equal to x plus 6 squared minus 2. And what this is this is actually a parabola, okay? And this parabola has a vertex of -6, -2, alrighty? And it faces upward. And let's see what this looks like. Let me sketch a rough graph. And forgive me because my graphs might not be as nice when I have like a rough graph like I'm making here. So this is -1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so -1, 2, 3, 4, 5, 6. -2. So -6, -2. Okay, then I'm going up 1, over 1, up 1, 2, 3. Yeah, there we go. Now what we're going to learn is that actually, this is actually pretty similar, this function here. So I've got my x actually going to be, if I plug in -2, that will go away, and I'll actually get -2, -6. And I can actually do all kinds of values here. Like I know that like 2, well, 2 plus 2 is 4. The square root of 4 is 2. 2 minus 6, that's -4. And so this is a really rough graph, but what we're going to learn is if I pretend like this doesn't exist, notice this beautiful symmetry about the point, this y equals x. This is the line y equals x. Now, the tough thing is, darn it, I've got this other piece. So if I reflect it, right, there's this other thing here that makes it not a function, and that's something we're going to have to investigate. But notice 6, -2. Or rather, -6, -2. -2, -6. See, the x and the y's are flopped. Okay? Here we have 2, -4. Here we have -4, 2. Okay, so see that flipping of the y's and the x's. That's actually a way to really easily generate a graph. Okay, let's go over here. This is the cube root. So here I'm going to do subtract 10. And I guess I could put it in parentheses. I don't really need to. Okay, now we're going to divide by 2 because we want to get the 2 out of there. Okay, now how do we undo a cube root? Well, what we're actually going to do is we're going to cube both sides. Because if you think about it, this is to the power of 1/3 because it's a cube root. Now, if I do some x to the 1/3 to the power of 3, these multiply and cancel. Similarly, what I'm going to do is I'm going to do this. And over here, all I have left is y minus 5. And then my last step is x minus 10 over 2 cubed plus 5 equals y. And in both cases, this is how you write the final result. So I write g inverse of x equals x plus 6 squared minus 2, that beautiful quadratic. And over here, I've got h inverse of x equals x minus 10 over 2 cubed plus 5. So those are my inverse functions, okay? So I really encourage you to go ahead and take a step back and take a look at these, okay? And make sure you understand them, okay? And then in a moment, I'm going to show you one where I'm going to give you a polynomial and ask you to go backwards, and then there'll be some for you to try. All right, so moving on. Let's try another one. So I'm going to give you g of x equals x squared plus 5. And I'm going to do h of x equals x cubed minus 7. And I want to know what are the inverses of these functions. Okay, so let's do one at a time. So first, remember, I'm going to let y equal x squared plus 5. This one I'm going to go a little faster. I'm not going to color code. So I'll start by switching. Right? Notice the letter switch. Now I'm going to move the 5 over. And how do we undo a square? Well, in this case, we're going to square root. Now, usually when we square root, we're like, all right, it's plus or minus. But again, in this case, it's not plus or minus. Because how many outputs can one input of a function have? It can only have one. So if I was to put a plus or minus in front of here, that's no good. Because what that means is it means that I'm getting two inputs, or rather two outputs for one input. So I get y equals root x plus 5, minus 5. And so therefore g inverse of x equals root x minus 5. What about this one? Similarly, let's let y equal x cubed minus 7. Let's pull off my switcheroonie. See the little flip? Okay, I'm going to add 7 on both sides. And then what root do I do here? This one's going to be the cube root, because the cube root cancels out the cube. And I get y. And eventually we are going to talk about cube root functions, and we'll really see some of the beautiful magic that those are all about. But for now, what we're going to do is we're just going to hang tight, and we're just going to graph this one out right here. What we're going to learn is that the cube root function follows the same kind of transformation rules that all the functions that we learned this year and last year are going to follow. Okay, and so last step is h inverse of x. And this should be, yep. So if you think about it, if I plug in the cube root into the cube, the roots would cancel, the 7s would cancel and have an x, and you'd get the same thing vice versa. If I plug in here, the 7 and the 7 would cancel. I get the cube root of x cubed, and that would be also x. All right, so I'm going to move on, and now it's time for you to try. Okay? So, sorry, I'm just going to grab some paper, and I want you to try right now. So here's my 2 you tries, and that will probably take us to the end. Here's 2 for you to try. So I've got f of x equals 2 times the square root of x minus 7. How about we just stick with x minus 7? The square root of x minus 7 plus 6. Okay, and I'm going to let g of x be 2 times the cube root of x plus 3 minus 10. I know I'm not the most creative number picker of all time. I got it. I totally feel you on that. So take a second, pause the video, try to find the inverse function of each of these, and then when you're ready, unpause the video, and we'll see if you're right. All right, here we go. So remember, this is f of x equals square root of x minus 7 plus 6. So the first step is replace f of x with y. Second step, switch the variables. And now let's isolate y. So I'm going to subtract 6 on both sides. Now, I need to eliminate this. So the idea is get the square on one side, the root on one side, all by itself. So now I can square both sides and get x minus 6 squared equals y minus 7. Now I add the 7 to both sides, and I get y equals x minus 6 squared plus 7. So my final inverse is f inverse of x equals x minus 6 squared plus 7. Okay? Quadratic with a vertex of 6, 7. Root with a vertex of 7, 6. When we talk about roots, right, the idea of, again, making it 0 will come back. All right, this one. So again, start with y equals do a flipperoo. Now I'm going to isolate the x, or rather isolate the y. So I'm going to add 10 on both sides. I'm going to divide both sides by 2 because I want just the root. And now how do I get rid of a cube root? I cube both sides. So I get x plus 10 over 2 cubed equals y plus 3. Okay, I now subtract the 3, and I get y equals x plus 10 over 2 cubed minus 3. And again, we can do a little analysis here. If I was to plug this in, back to my original function, right? If I was to take this and plug this in here, well, first what I'd get is the 3's would cancel, this would cancel with the cube, the 2's would cancel, the minus 10's would cancel, and I'd be left with x. And we can see that would work the other way around. So I want to take a second and use composition to show that these are inverses. So I'm going to start by doing g of g inverse of x. So I'm going to take g inverse, I'm going to plug it into g. If you don't know how to do this, again, please go back and look at my video on compositions. So now I'm going to take g inverse, I'm going to plug it into g. So g is 2, and now here I go. X plus 10 over 2 cubed minus 3. Okay. That's the thing that's getting plugged in. Okay, and the 10 is outside the house. This is actually a minus 10. Sorry if it's a little bit messy there. So what's going to happen? First, the 3's are going to cancel out. Right? These 3's cancel out. The next step is, well, this is a cube root of a cube. So the roots cancel out. Right? Because if you cube root something that's being cubed, this cancels with this. Now the 2's cancel. And by the way, these should be plus 10s because the rule is plus 10. Then the 10's cancel out, and I'm left with x. So that's check 1. Check 2, g inverse of g of x. Okay, if this is equal to x, they're inverses for sure. So now I'm going to take the original, I'm going to plug it in. All right, here I go. So I have 2 times the cube root of x minus 3 minus 10. Okay, that's what x is. Plus 10 over 2 cubed minus 3. So remember the rule. You take x, you add 10, you divide by 2, you cube, you subtract 3. Here's x. We're going to add 10, divide by 2, cube, and subtract 3. So here we go. First step, 10's cancel. So I get 2 cube root of x minus 3 over 2 cubed. And by the way, we just got to be careful. This is actually a plus 3. I'm sorry. I keep getting my signs mixed up. This is a plus 3 in the original. So you don't ask, like, man, why do you keep changing the signs? You're just doing that to make it work. Nope, that's the original one. Okay. Now the 2's cancel. And I get, let's come over here. I get cube root of x plus 3 cubed minus 3. Now I'm cubing something that's being cube rooted. The roots cancel with the power. I've got x. So when I plug g of x into the inverse function, I get x. When I plug in, the inverse into the original, I'm also left with x. Therefore, that proves they're inverses. Okay, that's how we do them. All right, so if you needed to better understand that, I encourage you to go back. I'm going to do one more you try problem. Here's what I'm going to ask you to do, just one more. Let g of x equal x squared plus 6 over 2. Okay, I want you to go ahead. Okay, I want you to try to calculate the inverse. And then when you're ready, we'll go ahead, unpause, and we'll see if you're right. All right, so remember, what's the first step? Replace with y. Second step, flip x and y. Now we isolate. So 2x equals y squared plus 6. So we multiply by 2. We subtract 6 on both sides. And then to get rid of the y squared, we square root. So we get y equals square root 2x minus 6. Okay, which in turn means that g inverse of x equals the square root of 2x minus 6. Let's see if we were right. Let's test it. So let's do g of g inverse of x. So I'm going to take the inverse. I'm going to plug it in. So what that means is I'm going to do this in pen because this is getting kind of confusing for me. See what it looks like. So first, the roots cancel. 6's cancel. 2's cancel. I'm left with x. Next step. I'm going to do g inverse of g of x. Okay, and when I do that, what I'm going to have to do is I'm going to have to do g into the inverse, which means start with my inverse. All right. And now let's take a look. So first, the 2's cancel. The 6's cancel. The x's cancel. The roots cancel rather, and now I'm back at x. So therefore, they're inverses. Okay, so this was meant to be a little quick crash course in how do we find inverses of functions. Remember, the idea is this is starting to tie things back together. How do square root functions and cube root functions and fourth root functions maybe, how do those relate to their polynomials that we recently investigated? This is a really important concept that's going to kind of wrap up our unit, and it's going to continue to build the unit up as we talk about the idea of using these roots just like we'd use, I don't know, addition to cancel subtraction, division to cancel out multiplication, okay? These are very closely related concepts. So I really thank you for taking the time to watch this video. I encourage you, of course, to go back through and review anything you want and keep the questions coming, folks. Keep the positivity coming. Try to look past the negativity because I know this is difficult stuff. I said at the beginning of the year, none of this would be easy. But remember, in the end, you can do it. Okay, so stay positive, stick with it. I believe in you. I really do. And have a wonderful day.